Hello everyone, I'm Jordan, a member of the Build Platform team at Canva. This is going to be a pretty quick one, so if you've got any questions, I'll be happy to answer them at the end. In this presentation, I will share some of the tips, strategies, and shortcuts we've discovered while migrating around 30 third-party projects, third-party dependencies at Canva. Most of these dependencies are now live in production, with the remainder set to be finished by the year's end. Some, like EOTU tools and GIFSQL, were pretty easy to bring over. Others, like Kara and FFmpeg, took quite a bit longer. All were previously managed by Nix. If you're interested in the rationale for why we are moving away, I recommend watching last year's Nix and Bazel, the odd couple of build tools lightning talk. Going off GitHub contributor stats, more people in this room will be familiar with the Bazel contribution process than BCR. To bring people up to speed and make the benefits of a product-first approach a little more tangible, here is an overview. BCR content is on GitHub, so the first step is to clone. Then you run the add module tool, which will ask for inputs like the module name to use, the version, the URL of the source archive, whether or not you want to patch the files, if you want to use an existing module file or generate a new one, some questions relating to setting up automated testing, and finally, for entirely new modules, it'll ask for the homepage and who should maintain it. From there, it'll go ahead and generate the module for you. That said, an important note about contributing to BCR and Bazel module development in general, don't start with BCR. You'll have a much more pleasant time using the built-in module overrides within an existing Bazel project. Get it working there, then turn your attention to BCR. Next is testing. If you've done things the right way, remove the module override in your project and make sure everything still works. At this point, you could raise a PR and throw it into review. Shouldn't though. The BCR has a battery of tests that it runs to ensure that every module has required metadata and is usable as a dependency. Run these locally before submitting to catch obvious mistakes, saving reviewers and yourself some time. Invest a little more time by adding a test module, and you may save yourself a hotfix or two later. Even better, you'll have advanced warning if a new incompatible flag breaks something. Finally, we can raise a PR and confirm BCR's checks pass. If all goes well, it'll be approved and merged. Done. It's a solid process for maintaining a healthy catalog, and in my opinion, is a good fit for Bazel. Difficulties. There we go. It's a solid process for maintaining a healthy catalog, and in my opinion, a good fit for Bazel, though it does have consequences. Compared to a fully automated registry like npmjs.com, crates.io, and PyPy, this is a lot slower. With that in mind, early on we tried an in-repo registry to serve as a complement to BCR. This was possible thanks to two features Bazel supports, the file URI scheme and the workspace path placeholder variable in Bazel RC, or just a relative file URI. Adding in the registry itself is a little tedious, but it's a cost you pay once. What this gives us is no conversion process when adding to BCR, a lot of automation potential since Bazel registries use JSON for all registry-specific metadata. With a little effort, BCR's own automations and checks can even be used. Unfortunately, these are overshadowed by flaws. While it is normal and expected that source archives need an integrity hash, registries also need hashes for every patch and overlaid file. Consequently, automation is needed to avoid becoming bogged down by such tedious work. However, the biggest issue by far is the immutability requirements. Recall the command for testing BCR changes. Before the module is set, the Bazel shutdown is run to restart the server, a necessary step to properly test changes. This is to clear the in-memory cache of registry files that are expected to be immutable. So, hypothetically, what would happen if we had an in-repo registry inside a monorepo with over 2,000 contributors and no guardrails to stop files from being changed once they've hit main? Nothing good. Our CI environment at Canva does not shut down Bazel between jobs to keep warm instances. As such, Bazel did not test a particular change that contained a defect. Everything seemed fine for a little while until a scale-up event occurred. Due to the nature of this issue, remediation involved more than just finding and reverting the bad commit. The version number also needed to be changed. However, we have a merge queue. To speed up recovery, a reset was necessary. That is, fast-track landing the fix in main, stopping all running merge queue jobs, and rebasing. With enough effort, appropriate guardrails for that mess could be implemented. But there are a lot of corner cases to consider for not just CI, but also workstations and dev boxes. The obvious lesson here is that an in-repo registry is a terrible idea. The bigger lesson is that manually managed registries are a big commitment since mistakes are easy to make and difficult to catch. I've covered the wrong way of doing things. Now onto the right way, non-registry overrides. This is a recommended approach. As of Bazel 8.5, it even supports the file overlay pattern available in registries. However, I can only recommend non-registry overrides when they're used for a small number of cheap modules. Reason being, if you have a lot of overrides, even with just one massive archive, or even just with one massive archive, these become a bottleneck. The problem is the module file. All must be collected in order for Bazel to resolve the dependency graph. To optimize this, registries include a copy of the file. Overrides have no such optimizations and must be fetched in their entirety. To address the performance issue, a compromise is necessary. Instead of defining an explicit module, we can use a repository rule and source dependencies from the main module. This addresses the performance issue. The conversion is also quick since module overrides rely on existing repository rules behind the scenes, passing most arguments verbatim. Because of the scale of our migration, this is the approach we used at Canva. It also addressed one mild annoyance. Bazel dep clauses not specifying a consistent version across all module files. The downside of this approach, of course, is that when it comes time to contribute to BCR, dependencies need to be manually located and copied out of the main module file. Since we are using repository rules directly at this point, why don't we eliminate some more busy work? Instead of explicitly listing each and every file, we can instead place it in a dedicated overlay directory and automate collection of inputs. The example shown uses a module extension as a thin wrapper around the HTTP archive repository rule. Behind the scenes, it expands the overlay path to a file sticked. At Canva, we used a custom repository rule. The downside of that approach is we ended up having to re-implement the HTTP archive functionality we care about. Whichever you go with, the important difference here is that files sourced from an explicit overlay directory have no file name transformations applied, making it necessary to instruct Bazel to ignore them. Otherwise, it may attempt to read a build file intended for a completely different repository. As the module extension depicted is not published anywhere, I'll be using HTTP archive for the remaining examples. While overlays cover the majority of use cases, there will always be come a point where existing code needs to be modified. Patches are the best tool for this, but they are tedious to manage. This was especially apparent in our migration, as many existing dependencies had already had patches. To that end, we created helpers which acquire the sources, apply any existing patches, and opens the current shell in a temporary location where edits can be made. When done, you simply exit the shell and patches are automatically exported. We have two variants of this helper, one which uses a Git repository as a source, and another for archives. For the moment, the implementation hasn't been shared publicly, for my part, because I've not been sure where it should go and how it should be surfaced. Alex's demonstration of the Aspect CLI and Aspect execution language yesterday has provided an answer, so that may change soon. Until then, these are the highlights. The snippet at the top produces a stable and clean patch files, which helps cut down on noise in code reviews. The bottom is the logic responsible for producing a stable base commit from source archives. On the topic of patching, one last-minute addition I've learned of on Sunday. Nested alongside patch args, patch strip, patch tools, and patches, which all deal specifically with patch files, there is patch commands. This lets you run arbitrary code in HTTP archive and Git repository rules. I personally don't recommend it, as patches serve most use cases while being deterministic with a predictable duration, but it's an extra tool at our disposal, which makes it worth sharing. It's also a useful escape patch if you need to modify a non-text file. The usefulness of the next few items is largely up to the characteristics and usage of individual projects. Most C and C++ projects out there use a few well-known build tools. While porting the build over to Bazel is generally preferable for better caching granularity and potentially faster builds, that does take time during the initial port and when updating. That's the scenario rules for NCC rule set addresses. It's not perfect, but it can save a bunch of time. Most of the dependencies who migrated used this rule set or used it in their initial implementation. It's a good idea to keep an eye out for specially prepared source distributions. As was shown in the last slide, Gisticle is a configure make style project that's light on dependencies, making it pretty easy to build with rules 4 and CC. There are also 2 options for source acquisition that are not entirely interchangeable. Build from GitHub sources and you need autoconf, an extra dependency that we didn't have set up at the time. Go with a prepared source distribution, however, and autoconf outputs are pre-built. This saved us a decent amount of time since we didn't have to add it to workstations, dev boxes, CI agents, and remote executors. Granted, supplying autoconf via Bazel would likely be quicker. Maybe. It wasn't necessary, so I have no answer. In a similar vein, there is no reason we can't simply take a snapshot of tricky outputs ourselves. When opting for rule CC over rules 4 and CC, as an example, you'll often be left to deal with configuration headers. If you're lucky, there'll be a template you can pass to a rule like expand template from Bazel Skylib. Otherwise, your best bet may be to generate the header using the project's existing tooling on each platform you're interested in and copy the relevant one into place at build time. If you're working on porting a Meson project, we can take advantage of 2 properties. 1, it does not support globbing, so all source files are explicitly listed in build definitions. 2, like Starlark, the Meson build language borrows Python syntax. This means filers can be truly copied over to Bazel. The single quotes are fine, it's valid Starlark, and Buildifier can normalize it. The great thing about open source is that just by being out there, there is a chance that someone has already tried to integrate a project with something. The cartographer project is a great example. We have a few dependencies in common, and while they could not be used verbatim, they served as an excellent reference. Other examples to look at are system package managers and language-specific package managers. In the case of Conan, it comes with an experimental code generator for Bazel, which may be worth taking a look at as well. It's worth acknowledging that not all dependencies made it across in our migration. Bazel is a highly scalable build tool, but not magic. Factors like build duration, resource requirements, hermeticity, and size play a major role in the suitability for a given integration strategy. In our case, Chromium. The source code is massive, weighing over 1.6 gigabyte without factoring in dependencies. Depending on the hardware, compilation can take anywhere from 1 to tens of hours. And the build definition, thanks to the scale of the project, is extremely complex. Luckily, all we really needed at Canva was a custom Chromium binary, so we could just draw a line in the sand and build this elsewhere. Chromium presents an extreme example across multiple metrics, so let's rein this in and focus on size. Currently, remote files must be eagerly downloaded in order for Bazel to complete analysis. This is a known bottleneck which solutions such as asset views, mentioned on Monday, are trying to solve. Unfortunately, existing solutions require some setup, making them a poor matchup for modules published to BCR. This is a ceiling for scaling that I'd love to see us break through in a manner where everyone benefits by default. I've got my own thoughts on how we might do that, and I'd love to hear from others. Let's take build without the bytes to the next level. Thank you. If there are any questions, ask away.
Hi there, Tony from Datadog again. You talked about grabbing the output of configure and turning it into a real rule. You know, I saw your select statement there. Have you built any tooling to help with that? I've done some, but I'd like to compare notes with other people who've tried it.
So this was, I'm guessing, the configure make I was talking about?
Yes, right,
okay.
Where you had the select on the config files.
Yep. So
right? The next page.
Next page?
The next slide where, I guess it was the select where you had the different configs.
Select.
Yeah, well, that's good enough, exactly.
The configuration header, yeah. So what was the question again?
So have you built any tooling to look at a configure, do a configure and then grab what's done and build you a build file that skips configure?
We have not.
Okay.
It would make things a lot easier if we did do that. There is a lot of permutations as far as what the configuration is.
Okay, we can talk after. I just wanted to see if you had. All right, thanks.